Good morning everyone. Today we will discuss about epoxide. Introduction. Epoxide are a cyclic ether having three-member ring in which oxygen is one of the atom. They are also known as alkene oxide or oxyranes. The simplest epoxide is ethylene oxide. Epoxide or oxyrane. Ethylene oxide or ethoxyethane. In the common system, epoxide are called as alkene oxide. In the IUPAC system, they are named as alkene oxide, epoxy alkanes, or oxyranes. The common and IUPAC name of some epoxide are given below for the sake of illustration. Ethylene oxide, ethene oxide, epoxy ethane, oxyrane. Propylene oxide, propane oxide, 1,2-epoxy propane, methylene oxyrane. 2-butene oxide, 2,3-epoxy butane, 2,3-dimethyl oxyrane. Cyclohexene oxide or 1,2-epoxy cyclohexene. The chemical behavior of epoxide is quite different from acyclic ether. Synthesis of epoxide. First, epoxide of alkenes. Epoxide are usually prepared by the reaction between an alkene and an organic peroxyacidic, also known as peracidic. The reaction is known as epoxidation. Alkene plus peroxyacid in the presence of epoxidation give epoxide plus carboxylic acid. Peroxyacid commonly used in the reaction of a pre-oxyformic acid. Pre-oxyacetate acid, pre-oxybenzoic acid, and parachloro pre-oxybenzoic acid. When a solution of a peroxide, acid, and alkene in ether or chloroform is allowed to stand, epoxide is formed. For example, 2-butene plus peroxybenzoic acid give 2,3-dimethyl ethylene oxide plus benzoic acid. Cyclohexene plus peroxybenzoic acid gives cyclohexene oxide plus benzoic acid. 1,2-dimethyl hexene plus benzone peroxybenzoic acid given reaction. It may be noted that epoxide of alkene is a stereospecific reaction in which the stereospecific of the substituted on the double bond is maintained. Thus, a cis alkene give a cis epoxide and a trans alkene give a trans epoxide. The reagent most commonly employed for epoxidation of alkene these days is magnesium monoperoxyphthalic mechanism. The mechanism of epoxide involves the transfer of electrophilic oxygen atom from peroxyacid to alkene as depicted below. Second, for halohydrines. When halohydrines prepared by reaction of aqueous solution of chloro or bromine with alkenes are treated with a base, HX is eliminated to yield an epoxide. For example, alkane plus chlorine plus water give ethylene chlorohydrin. Ethylene chlorohydrin plus KOH give ethylene oxide plus KCN plus water. Mechanism. The base attaches the halohydrines to abstract the hydrogen from OH part of halohydrines to form an alkoxide ion. The nucleophilic oxygen of alkoxide ion displaces the halogen from the adjacent carbon to form an epoxide as shown below. It may be seen that the reaction involves intramolecular, such that within the same molecule, nucleophilic substitution and is therefore treated as intramolecular Williams synthesis. It should also be noted that as in SN2 reaction, the attack of nucleophile takes place from the backside of CX bond. Third, manufacture of ethylene oxide. Ethylene oxide is manufactured by passing a mixture of ethylene and air under pressure or silver catalyst at 475 to 675 Kelvin. Ethylene plus oxygen in the presence of silver at 475 to 675 degree Kelvin give epoxide. Chemical reaction of epoxide. In contrast to acyclic ether, which are chemically quite inert, epoxide show high chemical reactivity. This is due to the highly strained nature of a three-member ring system. Ring opening reaction of epoxide. In the three-member ring containing oxygen, the carbon-oxygen carbon bond angle and the carbon-carbon oxygen bond angle are nearly 60 degrees each. The large distortion from the normal tetrahedron angle of 109.5 degree causes very large strain in epoxide molecule. As a result, epoxide undergoes a number of ring opening reactions quite easily. These reactions take place through the cleavage of one of a carbon-oxygen bond and may be either catalyzed by acid or brought about the bases or nucleophiles. Acid catalyzed reaction opening, ring opening. Just a simple ether undergoes cleavage of a molecule on reacting with acid. Epoxide undergoes ring cleavage on treating with acid even under mild condition. First, acid catalyzed hydrolysis. One of the most important cleavage reaction of epoxide is their hydrolysis to form 1,2-glycerol glycol. Hydrolysis takes place even in the presence of a dilute mineral acid at room temperature. Epoxide plus water in the presence of H positive give glycol. For example, ethylene oxide plus water in the presence of H positive give ethane 1,2-diol, ethylene glycol. Second, acid catalyzed reaction with alcohol. For example, epoxy ethane plus ethanol in the presence of H2SO4 give 2-ethoxyethanol. Third, reaction with halogen acid. Epoxide react with HCl and HBr to form chloro and bromohydrines. For example, epoxides plus HBr give ethylene bromohydrines. Mechanism of acid catalyzed ring opening. The mechanism of acid catalyzed ring cleavage may be illustrated by considering the hydrolysis of epoxide. In the acid catalyzed hydrolysis of epoxide, the epoxide is initially protonated by the acid. The protonated epoxide then undergoes nucleophilic attack by water to cause ring opening by breaking carbon-oxygen bond. The ring is complete by the loss of a proton as depicted below. Nucleophilic ring opening. Unlike simple ether, which do not undergo ring cleavage by a base or a nucleophile, cleavage of epoxide ring take place even by such reactant due to the ring strain in their molecule. For example, when treated with OH negative ion at higher temperature, epoxide ring gets cleavage to form 1,2-glycol. Ethylene epoxide plus water at presence of OH negative give ethane 1,2-diol. Mechanism of a nucleophilic ring opening. The mechanism of nucleophilic ring opening is shown below with the help of basic hydrolysis of ethylene epoxide. The strongly nucleophilic hydroxide ion attack the epoxide and displace the oxygen atom from the carbon by SN2 reaction. The product thus formed gets protonated to form the glycol as depicted below. Orientation of ring opening. Anti-addition. The ring opening of epoxide lead to the formation of product corresponding to anti-addition to carbon-carbon double bond. For example, acid catalyzed hydrolysis of cyclopentene oxide yield trans 1,2 cyclopentadiene. For example, cyclopentene oxide plus water in the presence of H positive give trans 1,2 cyclopentanediol. Rheoselectivity. Unsymmetrical oxirane can undergo ring opening in two different phases and generally lead to different products in acidic and basic medium. In acidic medium, the nucleophile generally get attached to the more substituted carbon, while on basic medium, the nucleophile being attacked to be less substituted carbon. Isobutylene oxide plus methanol in the presence of H positive give nucleophilic CH3OH negative attached to more substituted carbon as a main product. Isobutylene oxide plus CH3O negative in the presence of CH3O negative give nucleophile get attached to a less substituted carbon, means OH group is attached to a less substituted carbon. Explanation: the difference in reoselectivity in acid and basic medium may be justified as follows. In basic medium, the ring opening is an SN2 displacement by the nucleophiles on the protonated oxirane. As in other SN2 reactions, the attack takes place at the less substituted and less sterically hindered carbon. The less sterically hindered carbon undergoes SN2 attack. In acidic medium, the first step is the protonation of oxygen of oxirane ring. Due to electron releasing group attached to the more substituted carbon, positively charged oxygen attach the electron pair of its bond with this carbon to a greater extent than the electron pair of bond with the less substituted carbon. As a result, the more substituted carbon oxygen bond become weaker than the less substituted carbon oxygen bond. Therefore, ring opening takes place preferably at the more substituted carbon oxygen bond and the product contains the nucleophilic attack to a more substituted carbon. The weaker bond is partially attacked by nucleophiles. Other nucleophile ring opening reaction. First, reaction with Grignard reagent and organolithium reagent. Epoxide also undergoes nucleophilic ring opening reaction with Grignard reagent and organolithium reagent. The product initially formed on hydrolysis yield a primary alcohol containing large number of carbon atoms. The epoxide generally used in this reaction is ethylene oxide and the alcohol formed containing 2 carbon atoms more than in Grignard reagent. For example, N-propylene manganese bromide plus ethylene glycol in presence of ether give CH3, CH2, CH3, CH2, CH2O, MgBr. In the presence of H positive give pentanol plus MgOBr. N-butyl lithium plus ethylene glycol in presence of ether give CH3, CH2, 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 CH2OLi. In the presence of H3O positive give 1-hexanol plus lithium hydroxide. Second, reaction with alcohol. Ethylene glycol plus alcohol methanol in presence of CH3O negative Na positive give 2-methoxy-1-methanol. Reaction with ammonia. Ethylene epoxide plus NH3 give 2-amino-1-ethanol. Reaction with hydrogen cyanide. Ethylene epoxide plus HCN in the presence of water give ethylene cyanohydrine. Reduction with LiL4 gives CH2H CH2O or joined with Al negative Li positive. Loss in presence of water give ethanol plus LiAlO2. Write the formula and name product of a following reaction. First, when 1 cyclohexene plus water in presence of acid give 1 2 sorry cyclohexene 1 2 diol trans 1 2 hexene diol. Propene epoxide plus HCl give propylene 1 2 chlorohydrin. Thank you. This chapter is complete.